Let's go.
Audio Jungle.
Yeah. I really got the feeling today
Audio Jungle.
that everything is going my way. Now this is what I'm talking about.
Audio Jungle.
Every time I see your smile, it makes me shout. Let's go.
Audio Jungle.
Let's go. Woo-hoo-hoo. Nothing's gonna stop us today.
Audio Jungle.
Get on the bus or get out the way. We're cruising with the radio on.
Audio Jungle.
So turn it up to 10. Here comes our favorite song. Let's go.
Audio Jungle.
Let's go. Woo-hoo-hoo. Let's go.
Audio Jungle.
Let's go.
Hello and welcome to another episode of IoT Tuesday. I am yours truly, Samuel Atrani. Good morning, good afternoon, good evening, and I like to say good dawn to you wherever you find yourself on the continent. It's another Tuesday, and if you're feeling creative or feeling hacky or want to break some things and make some things, this is a show to be on. When we come back, I'm going to show you today how to connect the UV sensor and the light sensor as part of building our home environmental monitoring system. So stick and stay with me. When I come back, we're going to jump right into it. Awesome, we are back. We're back. Well, if you have been following us, we're building on incremental connecting sensors that we will need for our home environmental monitoring system. We've connected dust sensors, we've connected gas sensors, we've connected 4 displays, we've connected temperature humidity sensors, we've connected a varying array of sensors. In today's episode, we're going to see how to connect to the UV sensor as part of collecting UV amount in the environment we find ourselves in to know if it's enough for us to stay in or just the right amount of quantity of UV light we need. So we're going to get right into it. If you want to catch up on our previous episodes, connect to my social media channel, especially my YouTube. You're going to have all the shows we've been doing for the past couple of weeks on demand there for you to watch. And if you have any IoT specific stuff, questing project, we just want to, a second opinion on, or you just want to, ask, for just help, hit me at my social media handles at @sadrani and I would help you do that. Now, again, I've been talking about the Geek Store. We're patiently rolling it out, so worry no more. If you're thinking about buying IoT kits, buying sensors, the Geek Store is going to make sure you get that covered. So, let's just get right into it. Well, let me switch to the bench so we can show a few things that we have been doing over the past few weeks. So, if you have been following us, let me quickly pan this to this side. If you look over there, you will see a bunch of sensors, a bunch of stuff that's going on around here. Now, these are things that sensors that we've connected over the past couple of weeks, from the gate displays, from the gas sensors, and all that. Now, in today's episode, let me bring it right here. In today's episode, the concentration is on these. First of all, the UV sensor. This is how it looks like. If only our camera would focus. Please do. Let's turn it this way to see. Yeah, we have the UV sensor, all right, here. Now, the light sensor comes in two, variations. There is this one that's the conventional one that you probably would have seen in a couple of sensors here. And then there is this one, that looks like an LED, but actually it's not an LED, it's also a light sensor. So in today's episode, we're going to see how to connect these three, read values from them, and then we will continue to build upon our home automation system. So I must say that after today's episode, that will do it for all the sensor connections. And then from next week's episode, we'll start talking about device communications. So we'll talk about device to device communication, device to cloud communication, cloud to device communication. Because the notion is that now that we've connected our sensors to the board, how do we take the sensor data from, connected to our board? How do we send that to, let's say, our cloud services? And in this case, I think I mentioned from the beginning that we're going to be using the varying Azure IoT services, so IoT Central, IoT Hub, and all the cool stuff that Azure has to offer. So how do we take the data from our sensors, passed on to the microcontrollers to the cloud? So we're talking about MQTT, we're talking about some protocols that enable us to do that, and then we're talking about the Azure services as well. So let's get right into it. And first of all, let's start trying to connect the UV sensor. So as always, let's go here to our dashboard and welcome to you all of you that have joined us. Welcome wherever you're connecting from. Awesome. So as we do it, let's go all the way to, as usual, let's do our seed studio, and then we are doing UV sensor. And whilst that's happening, let me go ahead and open my Arduino IDE, not the app, the IDE itself. And I think I mentioned in a couple of episodes that there's a new Arduino Cloud IDE that has a lot of features and cool stuff. So go check that out in the previous episodes. Okay, so let's go here, Groove UI sensor. Let's open this up. Let me zoom this so you can see this properly. Okay, yep. Let's minimize it. So this is it. Yep, so this is the sensor we have, as you can see that. And as always, we always like to, you know, read a bit on it so we know what we are dealing with, what we are working with. So as seen is used to detect the intensity of incident ultraviolet radiation, the form of electromagnetic radiation that has a shorter wavelength than visible radiation. So it's based on this. So we at least let's see. So there has a wide spectral range of 200, okay, to 400. That's cool. So features: high stability, good sensitivity, low power consumption, Scotec type photodiode sensor, wide response range, groove interface, as you can see. Operating voltage, as always, we try to check this out. Operating voltage minimum 3, maximum 5.1. So our sensor, sorry, our Arduino and the hat should handle that. Current typical 0.31. Yeah, so looks cool. And here Arduino supported. So someone was asking, why am I doing most of these things on Arduino? And I'm like, well, because I'm using the groove sensors. Okay, um, they're a lot more easier to program on the Arduino, but we're going to connect the Arduino to transmit that data to something like the Azure Sphere, and then securely transmit that data to the cloud. So that's why I'm building I'm building upon the Arduino. So application ideas, as you can see, saying that, well, we can use the UV sensors for many different applications, including pharmaceutical, automobiles, and robotics. They are also used in printing industry for solvent handling and dyeing processes. That's true. And then in addition, the UV sensors are used in chemical industry for production, storage, and transportation of chemicals. So this is a theory of the UV. So this is a wavelength that it forms, and then gives us the illumination intensity between 3 and 7. So this is like the calculation for calculating the UV index. We're going to get into the intricacies of this when we finally put it together to build the application, because then we're going to know what levels are accepted and what levels are not accepted. All right. So as always, working through this, we have our kit ready to go, and then we can just do the connection. So here, if you look closely, they're connecting it to the analog 0 port, base shield, and then yeah, so port 0. And then we're going to copy some code from here and check it out. So let's go to the bench. So here we go. If I turn this around, you can see that this is my analog uh, right here, analog pin 0. Yeah, I don't know why. So anyway, that's it. So let's connect it to analog pin 0 here. That is connected. And then we're going to go ahead and connect it to the UV. And then I'm going to connect it to my computer. So actually, let me do this. I'm going to close my Arduino IDE. And I always like to connect it before opening the IDE so that the IDE would have time to, warm up and know what what Arduino is connected to what ports and all that. So yeah, quite something quite very simple as this. So let me just leave this here. Better still, yeah. Let me just fold this up here so it can sit well for me and have a lot of light, so to speak, so I can get some good readings. Okay, so that's set up. It's connected to Arduino. Let's come back here. Actually, let me use this view so you can see more of me. And then let's open Arduino, not the app. So, yep, the ID itself. And like I said, don't forget, if you have any questions, you can send them to me in chat. So let's go ahead and do file new. Opens a new sketch. Yep, zooming a bit so you can see. Let's get rid of all this code. We don't need this code. Let's go to, let's borrow this code. Bring it in here and paste. Let's ensure everything is fine. Okay, so we are opening the serial monitor so that we can output data to the serial monitor. That's what I mean. If you're following the channel, you should know that this is like a common thing we do several times. And then, uh, let's see. Hold on just a sec. I feel there's something missing here. Okay. I feel there's something missing here. Okay, cool. All right, let's go for it. So that's been set up. In the loop, we're setting the sensor value, and then there's another value here called the sum, and then we are checking if between I to 10, between 1 to 0 to 1 to 1024, that's the accumulated reading for 1024 times, is getting this. If the sensor value is equal to analog.read, because it's an analog port, it's going to read from, if you remember A0, that's how we connected it. If the sensor value, all right, is equal to this value, then the sum is equal to that sensor value plus the sum. Just like keep adding it to it. Delay for 2 seconds, and then we calculate it again, get the mean value, and then we print the current what index. So let's check if this code is correct without any issues. Obviously, yes. I'm going to save this, create a new folder, and let's call this UV. So in UV, let me call this sketch UV as well. So we've saved it. And if you look here, it's checking, validating this script or this sketch, so to speak. And that's good. So now let's push it to our Arduino. And that is done. Awesome. So now let's go ahead and tools, open our serial monitor, and let's check this out. Check, check, check. As you can see, so we're reading the UV sensor. Sorry, we're reading UV values from our sensor, and as you can see that, all right, we have values coming in. I'm trying to, actually block it. Okay, so there you go. So what I did was, let me actually switch quickly to the bench so you see what happened. So what I did was I just blocked it, like I used my finger to block it, and this is what we are getting. So because I'm blocking light from coming in, directly, this is what we are getting. And then when I release, I get this. I get -3. So it's like the mean or um, the average UV rating in my room right now, the office right now, is around minus 3.95. Yeah. Yeah. So that's how simple it is to actually connect the UV sensor. So we are within that range. Now with this done, let's go ahead now and see how we can connect the light sensor, okay, to see how it reads light into it. So I'm going to leave that running. Let's come back here. Let's go back to our, where is that? Let's go back here. And then now let's do the groove light sensor. Okay, let's see what version this is. So I mentioned that for the groove sensors, yeah, exactly. So there are two versions. Okay, there is this version, and then there is the very common version that has like the stripes on it, which I show. Let me actually take you back for those who are probably just joining us. So these are the two variants of the light sensors. All right, the two variants of the light sensors. Cool. So let's start with this one again. So just a little, you want to have a small write-up about it. Uh, let's see. And then, okay. So the groove light sensor integrates a photoresistor or light-dependent resistor to detect the intensity of light. The resistance of a photoresistor decreases when the intensity of light increases. So there's a dual ohm amps using the LM358. So as you can see, again, these are like the various iterations of it. And I think the second one we have, this is the 1.1. Yes, so this one is the 1.1, and then the one with like the LED is, I think, the 1.2. Yeah, cool. Okay. So features: analog values, high readability, small footprint, recognized wide spectrum. Obviously supported by all these boards. In our case, we are using the Arduino. All right, cool. And then operating voltage between 3 to 5 volts, we are safe. That's cool. So the peak wavelength it can read is 540, right? So let's get started. Again, so where is it connecting it to? So it's connecting it to A0. Now, but because we have the UV sensor on A0, I'm going to move it to A1. And now, once I move it to A1, I need to remember that and change it in the code to tell it that it's on analog port, what, A1. So let's go to the bench. Let me connect that. So this is A1. Yeah. Yeah, I need to have something that I can use to pin these sensors because of the JTAG cables. All right, so let me turn it this way. Yeah, so we can have, yeah, all of it here. Cool. Awesome. Now let's come back here. So remember we put it on A1, all right? And here they actually were using a bar LED just to show the intensity of it. We will not use that. So we need to get we don't need we don't need a groove library LED because we're not using an LED bar. So we don't need that. So we'll just go ahead. Um, well, we're not using the bar, so there's nothing in here for us to do. Now, so here, all right, quite simple. So we're going to copy this code. We don't need a bar, but we're just going to copy this code and I'll update it. Let me close right here. Okay. So in here, let's check this out. Okay, let's go here and then actually paste it at the top here. All right. So here, this is our value. Don't forget that this time we put it on A1. All right. So int value. So instead of the value, let's call it light. Let's call it light value. Okay. And then we can set the light value to this. So here it's saying we don't need here and then that's it. We don't need the bar set because we are not using any LED bar. We won't delay for anything. And then here, let's do the alignment well so we have this thing. So now we have the light value. Okay, let's do this. Okay, save this. So now we have the light value here that we can use. So actually, I can define. No, let's leave this here. So now I can copy this light value. Let's come here after reading all these. All right, let's see after reading it and going through this, or we can just let's do this. Okay, let's do serial.print the current. Let's say light index is okay, and yeah, that's it. You know, we won't print this. I'll just print it on a new line. Oh, sorry, not that, not here. That'll be here. So print a new line, and then actually print. So let's put a space here. Yep, we don't need this. We don't need this. Okay, let's save this. So all we are doing is that we're reading the light values, mapping it, and then printing it out before we going in to calculate the UV intensity or index. So let's check this again to make sure our code is fine. Awesome. And then let's deploy this back onto the Arduino. Looks like we're cool. Awesome. I'm going to go to tools and open the serial monitor. And now take a look at it. Light index is one because we mapped it. We mapped it from where's that? Let me show you this. Yeah, we mapped it. All right, between 0 to 8, and then we'll map between 0 to 10. All right. So that's like as of now, that's like the intensity seeing. So to make this work, what I'm going to do is that check this out. I'm going to use my phone's. So sorry about this, but I'm going to use my phone's light. All right, and then I'm going to shine this. Let me bring this close here. I'm going to shine this onto the light sensor. Now check that out. Now do you see that it's jumped from 1 to 9 because the intensity is now high. Now if I move my phone away from the sensor, a bit away from the sensor, check what's happening. The value has gone down. All right, if I move it even further away, the value goes down, 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 down. All right, if I take it close, the value goes up again. The value goes down. The value goes down. So sometimes in in the in the in the quest to build, let's say, a smart home or systems like this, you'll be asking, okay, so how can I detect there's light in the room? Apart from checking the current that's going in, you could also use a light sensor. So you know that when the light is on, you have a light sensor range from, let's say, between 5 and 9. All right. So anytime you're reading a value of 5 and 9, it tells you there's light in that room. And then if you remember the last episode, we connected the PAR motion sensor. You can find out, well, is there movement in the room? If there's not movement, but then the light is on, then it means that we're not being we're not conserving energy, so we can turn that light off. So that is how to also connect the light sensor. I could swap it for the old one, but that is as easy as it gets. So like I mentioned, this today's episode would end connecting of the sensors. Next week's episode will be concentrating on communication. So device to device communication, device to cloud communication, and cloud to device communication. That is what we'll be taking a look at next week. So until I come your way again next week with another episode of IoT Tuesday, as has been yours truly, Samuel Adrani. Stay safe out there. Let's show love, be kind, and hey, show some gratitude. Have a wonderful evening.